Hello, today we will be presenting you XRBars, a fast and reliable multiple choice selection by gaze in XR. Basically, what is this about? Accessibility is key for interaction, all types of interaction. We're talking about XR and we're talking about learning. XR has a few challenges about accessibility. As we know, wearable interfaces don't have the usual input devices, mouse and keyboard, where people are used to working with those. So we need to find other interaction methods. We're also talking about learning. Learning is a demanding process where we want the user's attention to be on actually learning and not trying to operate a complex system. For this project as well, we want to use the web as a learning tool. The web has various resources from wikis to dedicated learning platforms. We want to take advantage of what already exists in the web and allow it to be used for XR. For all of that, we need accessibility. And one way we found that is useful for XR and for all those different techniques is through the eye gaze. There are different techniques commonly used with XR interactions, such as hand motions or voice commands, but we find that that the eye gaze is less invasive. You don't have to interact as much with your environment. There's not as much risk of you hitting something. Unlike voice, you don't have to say things out loud, which might bother people around you. So eye gaze is the solution we're trying to use to tackle this, but it also presents a few challenges. The eye doesn't have an explicit selection mechanism, it doesn't have a built-in button where you can click and make a selection, so that can be a bit challenging. It has limited precision. Modern devices can be certain up to a certain point of what the user is looking at, but only within a certain area. So if more than one selectable object falls inside of that area, it might be a bit ambiguous of what you're trying to select. Finally, the eye is used for seeing things, and if we're also using it to select, it might be a bit of an overload, and we might mix a glance that is meant to read with a glance that's meant to select. So we need to find workarounds for that. Luckily, we're not the first ones to tackle this problem. Previous research has done a few of those things. Firstly, a common method is through indirect selection. Indirect selection is basically you find a way to move the small selectable elements into a larger selectable area. In this example, with a first glance, the system highlights nearby selectable elements, and then on a second moment, you can gaze on a sidebar, and the sidebar allows you to make a selection. The sidebar has larger buttons, making sure that there's no ambiguity of what you're trying to look at. Another approach is through assisted direct selection. Basically, you're still trying to point at the selectable element, but you're trying to make it easier to select. In this example, we're first glancing at a sidebar to allow us to zoom in onto the desired selection element, and then with a second glance, we start zooming in, and finally, at the third one, we can actually select the element. So this approach, both approaches have their ups and downs, but there have been other attempts at developing gaze browsers. What are we proposing? Well, both of those approaches rely heavily on dwelling, and we find that dwelling is a complex thing. If it's too long, it bothers the users and takes them out of the experience. However, if the dwell is too short, it's likely to make too many wrong selections. Dwell is a complicated thing. We propose the use of gaze bars. Gaze bars are a novel technique which works similarly to the indirect selection. Difference being instead of dwelling on the bar, on the sidebars, you actually don't dwell on it, you glance at it, and once you find the element that you're interested in selecting, you simply cross your eyes back into the center of the area. The system understands that, okay, you went looking for the bar, you found the element you want, you simply cross the eyes back and it will select the last element you were looking at. This allows the users to not have to worry about gaze dwell, and also allows them to speed up. If you quickly find what you're looking for, you can simply cross your eyes back without having to worry about how long do they need to gaze. And this helps them not divert their attention, making them the interface overall more fluid and making it easier for the users to focus their tasks they are actually trying to do instead of trying to operate the system. So this is XRBars. We're basically trying to combine that with a browser and create the XRBarser, which is the XRBars browser. And you'll see that it works similarly to what we've showcased before. You will first observe your region of interest. It will highlight different selectable objects in the area. You can then look at the appropriate gaze bar. So for example, the selection gaze bar is the bottom gaze bar. You'll find a desired option. In this video example, it's the option number 2. So you'll glance at it, and once you cross your eyes back at it, it will simply, since this is a hyperlink, redirect you to the page you want, simply by returning the gaze to the center of the page, overall speeding up the interaction. We have other gaze bars. So the side is not exactly a gaze bar, but it is a scrolling mechanism which allows you to scroll faster. Finally, the top bar allows you to manage different tabs. So by looking up, you will see various tabs which allow you to shift between different tabs, add new ones, remove previous ones, and that allows you to do a more complex browser where you'll also be using tabs. So what we'll be doing for our experiment? For our experiment, we'll want to explore all those functionalities and also validate that it's okay, it's actually being useful and it's actually being powerful and helping users focus on the task at hand. So for overall elements of the experiment, it will be an in-between subject, it will be an in-between experiment. Basically, we'll be testing various users on different interfaces. We want to test the different performance within a single user. Okay, how do they perform between different interfaces? So we'll be using state-of-the-art browsers and our own XRBars to figure out, okay, which ones do the users perform better, which ones they find they complete the task faster, which ones they give better subjective feedback. We'll be using around 20 users for that, and we'll be using a standard Tobii IX, which is a common eye tracking device. And with all of that, we'll be conducting in the experiment, trying to judge mainly by completion time, but also by subjective feedback. And the task we'll be trying to do is still a multiple choice test. We'll have one tab with a multiple choice question test where we'll have a bunch of questions and a bunch of answers. The questions are deliberately generic, so it will be Q1 and options A, B, C, D, Q2, A, B, C, D, because don't want the users to waste time trying to process the answer. We just want them to, okay, if they could simply find the answer immediately, how much time does the interaction take and not the processing power. So we'll be doing that. So on tab 1 is the questions, on tab 2 is the answers. They will be going back and forth between tabs 1 and 2 and as they see fit, and they will be scrolling up and down to answer the remaining questions on the page. Once they've selected all the questions, once they've selected all the answers, they can simply send, and this will be the size of our test, and we'll be measuring the completion time from beginning to end. We'll be taking questions to the user, we'll be asking questions to the user about their experience, and we'll also be evaluating, okay, how much time did they spend on each task, how often did they go back and forth, to evaluate the cognitive load of this whole process. So this is basically the idea of our experiment and what we're trying to do to help learning in XR.